Average atomic mass notes. More complicated averages. What is average atomic mass? Well, because there's so many different atoms of one element in the world, finding the mass of each atom individually is unreasonable. Instead, we find the average of all the masses of all the atoms that exist in the world. Therefore, AAM, or average atomic mass, is the weighted average mass of all the isotopes of an element. A weighted average is used for large groups of numbers. It takes into account the percent of the whole each item makes up. Regular averages are the ones you've done in math class since elementary school. You add all the numbers and then divide them by how many they are. Weighted averages are used when there's too many numbers or measurements to count, for atoms which are usually in very, very large groups. These are better. Weighted averages use percent abundance in their math, which in this case will indicate how common the isotopes are. Weighted averages to find AAM only use the non-radioactive isotopes of the element. Weighted averages have more steps to them than the usual add everything and divide by how many there are. First, you will match up each isotope with its percent abundance. Sometimes the problem will already do this. Next, you will divide all of the percent abundances by 100. This converts the percentage into a decimal so that we can do math with it. You still need to divide even if the percent is already a decimal. Next, we will multiply the isotope mass numbers with their converted percent abundance. Finally, we'll add all the results from step 3 together to find the AAM. For AAM, the periodic table is your answer key. All of the answers are there. If you check a tile, the answer will have the average atomic mass at the very bottom. In this, the weighted average uses the mass numbers of isotopes to find the average atomic mass for an element. Because of this, we are able to identify the more common isotope when given just the weighted average and the isotope's mass numbers. Because some isotopes contribute to the AAM more by having a higher percent abundance, the AAM is usually closest to the isotope that has the highest percent abundance. Here's our first practice problem. Carbon has two non-radioactive isotopes, carbon-12 and carbon-13. Their respective, or in order, percent abundances are 98.9% for carbon-12 and 1.1 for carbon-13. What is the average atomic mass of carbon? Practice problem 2. Oxygen has three non-radioactive isotopes, O16, O17, and O18. Their respective percent abundances are 99.76%, 0.04%, and 0.20%. What's the average atomic mass of oxygen? Practice 3 and 4. Copper has two stable isotopes, copper-63, copper-65. Based on its AAM, which isotope likely has a higher percent abundance? For this, you will need to check the periodic table, or you may check the resource we went over, ptable.com, for copper. Zinc has 5 stable isotopes, zinc-64, zinc-66, zinc-67, zinc-68, and zinc-70. Based on its AAM, which is likely the most abundant? You will also need to check the periodic table for this one.